Okay, so we have the what is this? It's the easy integral. It's the easy integral for July 10th. We'll see how it goes. This is not a comprehensive tutorial. This is literally just me trying it out, and just going for it. All right. So first things first, I'm gonna split these integrals apart because you have the plus. I got the big old plus right there, so I'm gonna split these integrals apart. I think that just, I think it just makes sense in the end, right? I'm supposing we do a u sub for this guy. Oh, whoops. Can't forget the dx. Cannot forget the dx. 2pi integral from 0 to 67 of... And then I'm assuming we're going to have to do a trig sub for this guy. It's x squared. I don't know if this size is good. Maybe this size is better. I don't know. It's kind of big though, Oh well. We'll figure it out. Maybe we'll just use the smaller chicken scratch for the entire thing. Okay. I'm gonna just forget about the trig sub real quick because I don't want to deal with that. Don't want to deal with that right now. So let's go over here. I actually just copy all of this. Whoops, I selected it. We're gonna copy all of this and we're just gonna move it over here. We're just gonna do this on its own. Okay, this is doable. Hopefully at least. So okay, I actually don't like this size. This is annoying me. U equals x over 6, 7. Which, of course, differentiate that, we get du equals 1 over 6, 7 dx. Coolio. Okay. So this means we have, so this is just going to be outside now. So it's going to be 2 over 6, 7 pi integral. So now we got to plug the x's in. So if you put in 0 over 6, 7 is still 0. If you put in 6, 7 over 6, 7 is just 1. Arc sine of u du. Cool. I do have an integral card, but I'm gonna try not to use it. See if I remember this. Arc sine, derivative of arc sine. Oh my goodness. Hold on, gang. Derivative of arc sine in my head is this? That's what it is in my head. Let me check this integration card. See if I'm right. Nope. Okay. Wait. No? I think not. I think that's fine. Although it's got to be in terms of u, of course. And then this is just a 1. Oh god, I can't remember the general form. This is what my card says. If we just have a just straight up arc sine of u. I'm looking at the derivative side. I'm actually crazy. I'm insane. Am I go crazy? You know what? You know what, man? I reckon it's probably just integration for parts, isn't it? Okay, so we're just gonna, I gotta remember it because I know I'm gonna forget about having that at the end, so I'm just gonna circle it just in case I forget. Okay, so we know that the integral of u dv is equal to uv minus integral of v du. So we choose something to differentiate, and we choose something to differentiate. Of course, we're not going to choose arcsine to differentiate, or not differentiate, but to integrate, because that is literally what we're doing. So we will just integrate du, which just becomes u. That's crazy. And then our u is just arcsine of u. And then, yes, this one. I would be able to get this one on my own. So it'd be the u squared. U squared, and we're writing in terms of u, so yeah, it's fine. That's okay. Oh, this u's a little scrambled here. There we go. Just do that. 1 over square root of 1 minus u squared. And then I like to think about it as doing this, and then multiply these guys. Okay. Let's do that. So we get u arc sine of u minus the integral of u over square root of 1 minus u squared. Du. I feel like I'm doing this wrong. Like, I feel like I'm doing this horrifically wrong. But we'll see what happens. I'll post this even if I get it wrong. And in fact, I think it'd be funnier if I posted it if I got it wrong. I'm gonna drag this guy up here. So I'm gonna hit him with that copy paste effect. Wait, we might have enough space. Yeah, you know what? We'll just keep going down. Just keep going down. But I'm gonna copy this guy. Put him down here. Okay. So we have this now. This integral, we're gonna have to do like a w substitution. So w equals 1 minus u squared. dw equals negative 2u. du. du. Which means du is equal to dw negative 2u. Okay, that's cool. That's cool. I can do that. I can do that. So we have, you know, still all this square root of 1 minus u squared dw over. Oh wait, I forgot to write the w inside of the square root. So w square root of w. So we just square root of w. And then du is now dw over negative 2u. These u's cancel. And we're just left with negative 1/2 integral of 1 over square root of w. So I'm just going to write this as w to the negative 1/2 power. That's just going to be easier for me. And then all we do, we just add 1. Add 1. And then we just divide by whatever we get. So negative 1/2 plus 1 is 1/2. So we divide by 1/2, which is just multiplied by 2. So we're left with negative 1/2 and then parentheses 2w to the 1/2 power. These guys cancel, so we just get negative w 1/2. That seems so incredibly wrong. Something is wrong here. Something's wrong. I can feel it. Something's wrong. I can feel it. You know, maybe I'm supposed to have like numbers here, right? Like how you normally do. But I don't know. You know what? Like, let's retrace our steps, right? Maybe that'll help. So I was like, hey, let's do a u sub. And then I did do a u sub. It didn't quite get us there, but it did lead us to be able to do integration by parts. So that's fun and cool. That's fun and cool, I guess. Maybe so we have 0 and 1 right here, right? We have those. Maybe we put them into w. So like if you put in 0, we get 1, so there'd be 1 at the bottom, and then if you put in 1, you get 0, so 0 would be at the bottom, 0 would be at the top. Would that even make sense? Would that even make sense? That's the real question. That doesn't feel right though, because I don't think I've seen integrated by parts with like numbers on like when you're just doing the integrals, right? Oh, you know, I just put it back in terms of u. Duh. Okay. That makes no sense to me. So w actually equals, you know, the 1 minus. So w is actually, just put in the square root. So negative 1 minus u squared. There we go. Cool, I guess. So this tells me that in total we have u arc sine u minus the integral, this integral. So it's, yeah, minus this integral, which equals this thing. So a negative times negative is just a positive. So boom, and then square root 1 minus u squared. Something tells me this is wrong, man. I don't like this. And then, of course, wait. Okay. We'll go from 0 to 1, and then we'll multiply it by, what was it, 2 over 5? I think it was 2 over 5. That's not 2 over 5, that's 2 over 6, 7. 2 over 6, 7 pi. Oh, dear Lord, please tell me this is right. Anyways, if we put in 1, we get 1 arc sine of u. So arc sine of u to equal 1. So that is saying what theta angle, so what pi over what would make it so it is 1? Hold up. Because we have sine theta equals some blah blah blah. Like your y, it's your y, right? Which means your arc sine of y equals theta. So what theta gives you 1? Is that what it's asking? Is this calculator approved? Is this TI-84 calculator approved? Am I like overthinking this right now? Because in my head it's just square root of 2 over 2. I'm just typing it real quick. Never mind, it's not square root of 2 over 2. Ooh, okay, I'm crazy. I might be crazy. You know what? Let's just write it out. Let's just write it all out and see what happens. So we have 2 over 6, 7, 5. We have 1. So we have 1 arc sine of 1. Arc sine of 1. Because I know arctangent of 1 is just pi over 2. Square root of 2 over 2. Not square root of 2 over 2. It's pi over 4. Oh my goodness. Okay. For some, why do I keep getting that mixed up? I'm actually insane. Okay. So we put in 1 into this whole thing. What theta gives us 1 for sine? Pi over 4. This is just pi over 4. So pi over 4. Plus, so if we put 1 into there, 1 minus 1 squared, so it's just 1 minus 1, which is 0. So we really just have pi over 4. Minus, if we have 0, so if we put in the zeros into the u, this guy just cancels all of that out. And then 1 minus 0 is still just 1. Square root of 1 is still 1. So we have this. So it's just 1. Oh god, this feels so wrong. There's no way. There is no way, dude. Okay. So we get... I'll just simplify this real quick. This goes bye-bye. This becomes 2. And then these pi's cancel out. So that's 1 over... 134? Minus 1? Is that 134? 6, 7 times 2? Yeah, 134. Just gotta make sure. I don't trust myself sometimes. 134 equals negative 133 over 134. Oops, I didn't even write the... There you go. We are gonna decorate this guy. Just so I don't forget him. He's right there. My guy's right there. Oh, wow. Yeah, we can, like, really just move all this. So, let's do that. Let's just move all this so we can have it a little more clean. I'm gonna move this. So it's up here. Oh, wait. Whoops. I'm gonna... Boom. Bam. Bada pop. Bow. Oh my gosh, I can't. There you go. I'm so cool. Okay. Let's just shrink this. This is a little big. We don't need it too big. Scooch him over. Scooch it over. Put it right over here. Safe for safekeeping. Just put it over there. Okay, now tricks up guy. This guy. Oh, whoopsies. This guy right here, tricks up guy. We're gonna 2 over really smaller. 2 over pi 6 7 over 0 x square root of 6 7 squared minus x squared. All right, let's make a triangle and try and think about. We could do this. So it's not tangent. So x is not going to equal tangent theta. So it's either sine theta or secant theta. Let's try secant theta. No, let's try sine theta. Okay. So if the x squared is negative, that means we had to move the x squared over, which means this is x squared. This is 6 7 square root of, this has to be square root of 6 7 because we're going to be squaring these. And then this is square root of 6 7 squared minus squared. And just to double check, x squared plus b squared equals square root of 6 7, or which should just be 6 7. So you move the x over. Yes. Wait. Nope, this is just 6 7. I think that's just 6 7. Eraser this guy out of here. I think that's actually just 6 7. It's not even like square root of 6 7. This is straight up 6 7. Because this is 6 7 squared now. Cool, because it would have been square root of 6 7 squared, which would have just been 6 7 anyway. So it's like, yeah, it's just 6 7. Okay. Cool. So we will use x equals sine theta. I gotta, oh shoot, whoopsies. I just kind of want to erase some of the check work here. It's just kind of not needed anymore. I want to erase the triangle though. I'm pretty sure I'm gonna need that triangle in a bit here. Let me grab my pen. I'm like couldn't find my pen. I've got to write dx here. Sine theta. Actually, oh shoot. Sorry, I just want to keep it all tidy, you know. I want to keep it all tidy. X equals sine theta, which means dx equals cosine theta. I'm like pretty sure there's something I'm supposed to do. Ah, right, the differential d theta, right? Okay. Let me think about this. Oh, x squared is sine squared. Yeah. Oh, wait. It's not just sine theta. Is it just sine theta? Oh, God. Oh, wait. No. Because we also have to know that, we also know that sine theta is equal to, so opposite over hypotenuse, it's going to be that x over 6, 7, right? Which means that x is actually equal to 6, 7 sine theta. Right. Cool. 6, 7 sine theta. Okay. So this is 6, 7 cosine theta d theta. Cool. Yeah. I figured it out. I figured it out. I've actually never done trig sub with a non like there's numbers. I forget what it's called. I can't believe I forgot, but yeah, like we'll do the numbers. I'm assuming I just put these numbers because this is x equals 6, 7. This is x equals 0. So when x equals 0, this is just 0. When x equals 6, 7, it's just 1. Or sine theta equals 1. So then it'd be... Okay, hold on. I'm gonna just write out what I'm thinking. Okay. Sine theta equals 6, 7 over 6, 7, as we stated over here, because that's what the x equals 6, 7 at the top is, right? Which just equals 1. So sine theta equals 1. And then we do arc sine on both sides. So it'd just be theta. Theta equals arc sine of 1. And we know that the angle that makes, arc sine of 1 is pi over 4. Let me just fact check this because I really don't believe myself right now. I feel like I'm making stuff up and the math is just happening to work out. I think I'm lying to myself. Hold on. Oh my god. What angle makes sine equal 1? It's pi over 2. It's freaking pi over 2. I'm so done. I'm freaking done, bro. Alright. Okay. It's pi over 2. Which means I got the other thing wrong. I'm gonna go fix that right now. Okay. Hey, you. You're not pi over 4. You're pi over 2. You're pi over 2. That does make more sense, though, because it's like a less messy number, So it's like, hey, this is... let me get my brush. This is pi over 2. That's what that's supposed to be. So then this all cancels out. So it's just 167 minus 1. Okay, I can do that now. That makes sense. It all makes sense. Okay. So, yeah, it's just 167 minus 1. So, 1 over 67 minus 1. So this will equal negative 66 over 67. Oh, look over here. This is your next. This is like the thing you need. 1 minus 67 is negative 66, right? I'm gonna just take my word for it. Okay. Oh my goodness. Okay, yeah, I'm actually brain farting. Anyways. Cool. I'm so cool, dude. I'm like so sick with it. Okay. So, a lot of things. We know a lot of things. Wait, have we even figured this out yet? Yeah. I think we're good. So we have 2 pi integral from 0 to pi over 2 6, 7 sine of theta over square root of 6, 7 squared minus, and then this will just be 6, 7 squared sine squared theta cosine 6, 7 cosine theta d theta. Yeah, buddy. Wait. Yeah. Not even worried, baby. Not even worried. Okay. So we read everything out. 2 to pi over 2. We get you know, 6, 7 sine theta. And then we can bring out a 6, 7 squared, which means this is 1 minus sine squared theta. 6, 7 cosine theta d theta. These square roots cancel out. They go bye-bye. Which means we just have a 6, 7 on the bottom. And there's a 6, 7 on the bottom here. It's being multiplied. And then there's a 6, 7 up here. These 6, 7s, they just go bye-bye. No more. All gone. Never to be seen again. All gone. It's okay. 2 pi. Integral 0 pi over 2. So we know this is just going to be cosine squared theta. And then we have the square root. So it's just going to be cosine theta. And then we have 6, 7 sine theta. And then we have cosine theta d theta out here. These cosines cancel out. I love that. We can bring this 6, 7 out to the front. 6, 7 times 2 is 134 over pi. Integral from pi over 2 to 0 of sine theta. Wow, that's so easy. I can do that. I can do that for you. Awesome. We have 134 over pi. Let's see. What am I thinking? Let me check if we're still recording. Yes, we're still recording. We're doing good. Okay. Lovely. Integral of sine theta is negative cosine theta. Let me think about this real quick. If we integrate negative cosine, the c means that there has to be another negative. So negative cosine. So cosine usually just becomes a negative sign. So the negative sign, and then you put the negative on, and then boom, you get the positive sign like it is right here. Okay, cool. It's all working out. We're gonna plug in 0 and pi over 2. It's cool. I can do that. 134 over pi. Negative cosine pi over 2. I'm gonna write these in red, just so we can all differentiate these from each other. Minus, so we're just gonna be plus cosine of 0. Boink. Okay, this is doable, guys. This is very doable. So cosine at pi over 2 is normally 0. Negative 0 is just 0. Holy moly. Cosine when theta is 0 is 1. So this just becomes 1. So it's just 134 pi. 134 pi. That's our other number. Whee! Oh my god, guys, look at it. It's so cool. This is not right, dude. There's no way. Oh, dude, there's no way. There is no way. Wait a second. What? Wait a second. This 2 pi has to go into this 1 as well. Wait, what did I even do here? I only plugged in 1? No. Hold on. Oh no, so this is 1. This is when I plugged in 1. This is when I plugged in 0. Okay. So I still got to times by 2 over 6, 7. Which means this is still 1 over 6, 7 over here, minus this 2 over 6, 7, which is negative 1 over 6, 7. Oh my goodness. I triple backed to this. I triple backed. There's no way. There's no way. This can't be right. No. So you're telling me. Hold on. Let's zoom this out real quick. Oh my god, sorry. So we're adding these two integrals. We are adding these two integrals together. So which means we have 134 pi plus. Wait, was it minus? Yeah, negative minus 1 over 6, 7. Dude, something ain't right, dude. Something is not right, dude. I got this wrong. There's no way. There's no way. Times by pi, times by 6, 7, times by 6, 7. So then we have 6, 7 pi. That's a... No, no. I am in disbelief. There is no way this is right. No, no, no way. There's no planet. There's no shot. There's no shot. Yeah, okay. Whew. There's no way that's correct. Because there's a lot of 6, 7s here, I can only assume that I'm messed up somewhere here. And I should have put a 6, 7. Something about that just don't feel right, man. So let's see. Let's like really think about this. I think most likely where I got wrong is this trig sub right here. I think this is... Oh, wait. No? Wait. Do I just... Maybe I should just convert it. Wait. Maybe I should just do it in terms of X instead? Okay. Plan B. We're gonna do this entire part, but we're gonna do it in terms of X this time. We're gonna do it in terms of X. And see if that possibly changes anything, because I am kind of stupid sometimes. And I tend to screw things up. So let's just take a little gander, alright? Let's take a little gander. So this is like the first answer you get. I'll hide this guy like corner over here. Actually no, I'll hide him like over here. Boop. Okay. So let's take a look. Let's think about this. Let's think about this. Yes. Thank you, me. We have cosine theta. If we look here at our triangle, cosine theta is adjacent hypotenuse, which means cosine theta is just square root of 6, 7 squared minus x squared over 6, 7. And then we're supposed to put 6, 7 and 0 in here. Okay. Makes sense. It makes sense. And then the 134 pi. I really don't like that. Like, something's off about that, man. I don't think this 134 pi is supposed to be here, man. But there's like there's no way I can just pull out a pi and cancel out the pi. So I guess I have to assume that there's just a pi in there somewhere, right? Like, I guess that's my only option. Anyways, yeah, I'm just like staring at it. So if we plug in 6, 7 into here, into this x, so it'll be 6, 7 squared minus 6, 7 squared, which is 0. So that means we just have 0 minus. If we plug in 0, we get a square root of 6, 7 squared, square root of 6, 7 squared, which is just 6, 7. 6, 7 or 6, 7 is 1, so it's just 134 over pi. Okay. No, something's wrong, man. No. No. Something's wrong. Okay, what the heck? I'm looking at this like way more in depth now because I've been looking at this for like an hour. Why is this a minus? This clearly says plus. It clearly says plus. Does this change anything? I don't know. I hope it does. So we'll see what happens when that's a 3 instead of a -1. Put in my calculator real quick. So 42.7. Dang it. Okay. That's fun. Yeah, I reworked the entire trig sub problem. I don't think I did anything wrong with the trig sub, so I think it's just down to this one. I don't know, man. Oh dear God. You know, I just realized I forgot to put the let me zoom in on it. I forgot to put the pie right here. Um so I'm doing it here now. See what happens. Please, please tell me this is the answer, man. Please, I'm begging you, man. I'm begging you. Come on. Come on. Big money, man. Big money. So this is like I won't really give the number because you're supposed to like slap these two together. Like, you just do stuff. So we have that. So we have whatever this gives us minus the 134 over. Oh gosh, excuse me. 134 over. Let me just make sure I'm doing this right, because so you do the arc sine one first, which is that's this number on my calculator. That is. See what we got. Plus. Okay. Plus the trig sub one. Which the trig sub one was 134 pi. 134 over pi. 42.57. Is that what it says? Yeah, I'm like doing this in the dark, so I can't see. Ah, what? No. No, man. Oh, no. Unbelievable, man. What do I even do? Oh, I'm so missing something. I've been doing this for way too long. Yeah, I need to get some rest, so. Dang, I really thought, I really thought I had it, but I guess not. Well. Oh well. I tried. Good run. Yeah. Good night.